Good morning, students. In this session, let we discuss about fertilizer plant. So here we will be seeing about the manufacturing process in the fertilizer industry. That is how the fertilizers are being manufactured, as well as the various wastewater that is originates from this fertilizer industry, its characteristics, and its effects when it is get disposed of into the stream. Finally, the treatment of this fertilizer industry wastewater. So let's go with this session. Before to start with the fertilizer manufacturing process, let's recall what are the types of fertilizers we have come across so far. So normally there are three types of fertilizers. One is nitrogenous fertilizers, second one is phosphatic fertilizers, and third one is potash fertilizers. Under nitrogenous fertilizers, the fertilizers like urea, ammonium sulfate, ammonium nitrate and ammonium chlorides are there. So under phosphatic fertilizers we have superphosphate, as well as we can make a combination of ammonium as well as phosphate together and make as DAP, that is diammonium phosphate fertilizers, and finally potash fertilizers. So these are the fertilizers normally we use in our agriculture field. So when we come here, this potash fertilizers is drastically different from that of your nitrogenous and phosphatic fertilizers in the manufacturing point of view, where in this potash fertilizers there is no need for extensive chemical treatment or chemical processing. Here just directly from the potash ore we get the potash and we process it up, that is from the mining we get the potash and we process it up and we can directly give it as potash fertilizer. But that is not the case in case of nitrogenous fertilizers as well as phosphatic fertilizers, where it has a series of manufacturing or chemical processes where this carbonaceous materials is turned up into this nitrogenous or phosphatic fertilizers. So we will see one by one how this nitrogenous fertilizers are manufactured and how this phosphatic fertilizers are also being manufactured. So first, under nitrogenous fertilizers, let's see about urea manufacturing process. In case of nitrogenous fertilizers, whether it is urea, ammonium phosphate or ammonium sulfate or ammonium nitrate, even ammonium phosphate also, the main intermediate in all this nitrogenous fertilizer process is the production of ammonia. In certain industries, they will be having only ammonia manufacturing unit. In certain other units, it will be combined with it of the urea as well as the ammonium phosphate or ammonium sulfate manufacturing units. So what is there in urea manufacturing processes? The main step in all of this nitrogenous fertilizers, as I already said, we have to produce ammonia. So how to produce this ammonia? So first we'll go with the production of ammonia. Then after ammonia is been synthesized, then we can, from that we will be able to synthesize the urea. So first is we will have the carbonaceous materials like naphtha. It is allowed to react with the steam and air, which will be resulting in the synthesis gas. So this synthesis gas is comprises of hydrogen as well as carbon monoxide. And once again, this carbon monoxide, it will be allowed to react with the steam under a catalyst, so that it will be finally converted into further hydrogen as well as carbon dioxide. So our main aim in all these things is to separate and purify this carbon dioxide. Why? Because this carbon dioxide is essential for the manufacturing of urea. And if there is any removal of residual carbon monoxide is there, we have to remove it from the gas mixture. Then how this ammonia is synthesized is by reacting this hydrogen along with the nitrogen. In the presence of a catalyst, we will be able to synthesize ammonia. So the hydrogen, what is formed in this carbonaceous materials, it is allowed to react with that of the nitrogen. With the help of a catalyst, it will be results in the formation of ammonia. While the carbon monoxide is turned once again into carbon dioxide, and this carbon dioxide, it will be allowed to react with that of the ammonia in a reactor at high temperature and pressure, where it results in the formation of urea. So this is how the urea is manufactured. So for the manufacture of ammonia, we need hydrogen and nitrogen, and this hydrogen is formed from the carbonaceous materials. And similarly, for the manufacture of urea, we need ammonia and carbon dioxide, where this carbon dioxide is once again we are getting it from the carbonaceous materials. So when we see the other manufacturing process of the other fertilizers, say ammonium sulfate is the other fertilizer. We have seen the other nitrogenous fertilizers. Under that, first one is urea and second one is ammonium sulfate. So how we do it? We have to get the ammonia, production of ammonia. So after the synthesis of ammonia, it will be reacted with that of the sulfuric acid. So we will be getting ammonium sulfate. Or instead of sulfuric acid, we can it may be allowed to react with that of the gypsum or with the calcium sulfate sludge. So this calcium sulfate sludge is normally will be getting from the phosphatic fertilizer plant. So it is a residue what is collecting from there. It can be used here for the production of ammonium sulfate. So that could also be done. And second one, suppose instead of urea and ammonium sulfate, we need ammonium nitrate. In that case, this ammonia is allowed to react with that of the nitric acid so that it forms in the ammonium nitrate. In case of phosphatic fertilizers, first one is your superphosphate. So in case of superphosphate, the phosphate ore what is coming from the mining industry, it will be allowed to react with it of the sulfuric acid. As I already said, the byproduct of this process is calcium sulfate, which could be used in the manufacture of ammonium sulfate. And similarly, if you want to make ammonium phosphate, that is phosphoric acid will be reacted with it of the ammonia, and here also will be able to get the byproduct calcium sulfate. So what happens here? So they will combine the phosphoric acid and ammonia in a reactor, and it will be allowed for a specific period of time so that the calcium sulfate crystals will be formed. And this calcium sulfate crystals can be get separated from the rest of the solution, and this calcium sulfate can be used as a byproduct, whereas the rest of the solution can be get concentrated and it can be turned into a fertilizer. So this is the flow diagram which shows you the production of urea. So in this case, you will be able to see the different phases of this urea synthesis. First one is your gasification phase. As I already said, the naphtha or natural gas, which is along with the carbonaceous materials, it will be subjected to air as well as steam. So what happens here? It will be converted into carbon monoxide, hydrogen as well as the other gases. Then once again it will be subjected to air and steam, whereas the carbon monoxide, which is not reacted, it will be further converted into carbon dioxide, hydrogen and nitrogen. So it will be taken to the gas absorption tower where it will be get purified, and then it will be sent to that methanator. Okay, so in methanator we will be able to get the methane. From that we will be able to get hydrogen as well as methane. Then it will be sent to that of the compressor and finally to the ammonia synthesis plant, where in this case of ammonia synthesis plant, this nitrogen as well as your hydrogen together will be reacted and it will be forming the ammonia. And if there is any excess gas which has to be purified, it will be removed, otherwise it will be sent to the cooling tower and then it will be taken to that of a urea plant. So here the carbon dioxide which is coming from this for initial process, it will be taken to the reboilers, and from that the reboilers it will be taken to that of the urea plant. So here the first stage is your gasification stage, where the carbonaceous materials will be converted into the respective gas. Then in the second stage is a gas separation stage, where it will be get separated into carbon dioxide, hydrogen as well as nitrogen. And third stage is your ammonia synthesis, where this hydrogen and nitrogen together it will be reacting and it will forming the ammonia. So the last stage is your urea synthesis process. So as I already said, the first three stages, gasification, gas separation and ammonia synthesis, is essential for the production of all type of nitrogenous fertilizers and even the phosphatic fertilizers like diammonium or phosphate fertilizers also you will be able to go for ammonia. So ammonia is a principal intermediate in the manufacturing of all these fertilizers. So when you come for the urea synthesis, so this ammonia along with it of the carbon dioxide, it will be reacted in the urea autoclave, where it will be converted into urea, which will be further heated, filtered as well as crystallized and centrifuged so that the urea crystals will be formed, which can be collected in the prilling tower and it can be packed. So this is the normal process of manufacturing of urea. So as I already said, once if the ammonia is manufactured, we will be able to convert, will be able to synthesize the urea or ammonium sulfate or ammonium nitrate or ammonium phosphate as per the requirement what is required by the industry. So when you see the wastewaters that is coming from this, you could be able to see that there are condensate leakages, boiler blowdown, okay, and carryovers and other leakages that is coming in the synthesis of ammonia as well as urea plant. So that are the wastewaters that is coming out from that of your fertilizer manufacturing unit. So what is the composition of this waste that is coming from this complex fertilizer plant waste is pH will be normally in terms of alkaline range, so it is 7.5 to 9.5, while total solids it's 5400 milligram per liter. So we have to specify the units everywhere, and here also the total solids it has to be like 5400 milligram per liter, and ammonia nitrogen is 700 milligram per liter, urea nitrogen is 600 milligram per liter, phosphate is 75 milligram per liter, fluoride is 15 milligram per liter, and arsenic is 1.5 milligram per liter. See, unlike other industries like sugar industries, dairy industries, we don't have here COD and BOD. Instead, we will be having either everything in terms of your fertilizers. Okay, that because that is the main product what we get. So that we don't have here COD and BOD, which is consisting of your organic content. So ammonia, urea, and phosphate, fluoride, and arsenic are the various waste that is coming out from the fertilizer plant waste. So what is the effects of this waste when it is subjected to receiving streams? As we all know, this ammonia waste, it has alkalis as well as acids, because we are using acids for the processing like sulfuric acid, nitric acid, etc. So when it is discharged along with it of the wastewater, it will be destroying the aquatic life in the streams. As well as if there is arsenic, fluoride, and ammonium salts, we could be able to see from the characteristics of the waste. And this waste, when it is subjected to that of the stream, it will be toxic to the fishes. Apart from that, amines are also toxic to the fishes, and it exerts a high oxygen as well as the chlorine demand. And since there are presence of different types of salts or there, it will be normally rendering this streams unfit for its use. And presence of nitrogen, it's very important because nitrogen and phosphate are very important sources for the production of algae or aquatic plants, which will be resulting in algal bloom, which will also result in eutrophication. As we know that eutrophication is the presence of algal bloom in the lakes and ponds, which will be devoiding your sunlight penetration, so automatically it leads that particular lake into anaerobic conditions, and which also results in that of your eventual death of your aquatic plants, flora and fauna in the particular zone. So that is a main drawback when we discharge this wastewater along with nitrogen and phosphate into that of the receiving streams. So when you come to the treatment of your fertilizer plant, main thing is here we have to concern with it of the ammonia plant and urea plant, where we get ammonia as a waste product. So that is the main thing we have to go for treating it up. So there are various ways for treating this ammonia, but the most beneficial is your nitrification and denitrification process. So from the ammonia plant, what are the waste we receive that contains ammonia, as well as from urea plant, which it contains ammonia and urea, it will be taken to the nitrification units as well as denitrification units, where it will be converted into a nitrogen product, and then it will be get removed, and the final effluent will be get discharged off. Apart from that, in ammonia plant we will be having arsenic bearing waste, so that has to be separated and it has to be sent to evaporation. And once the residue is got, we will be disposing it off safely, while the other things will be get sent to the effluent plant. And main thing is this ammonia plant will be having oil bearing waste, because of the oil that is used for maintenance and also for the other things. So it will be it has to be taken to the oil separator, and once the oil is separated, it can be treated with that of your effluent. Main thing in any industrial waste is segregation of the waste is a primary important. As I already said, how we have to segregate is, one is the manufacturing process waste, so that which is having high concentration of pollution compared to that of the other waste like sanitary waste or housekeeping waste. So this manufacturing process waste only we have to be concentrate much because it may have toxic or heavy metals or high organic content, depends upon the industries, and hence it has to be get treated to that specific purpose. Other than that, if it is housekeeping waste, it is the waste that is coming from that of the floor cleaning or the equipment cleaning is not much going to concentrate on this. It's not going to contribute to this pollution. Okay, so in this case, and similarly sanitary waste also, it's not going to contribute much to that of the pollution's load, so that it requires only a simple treatment, while the toxic waste as well as other heavy metals, it requires a specific treatment before it is get discharged into that of the stream or into that of the sewer. So apart from this ammonia plant and urea plant, where it contains mainly ammonia and urea, there are the other units like boiler plant, ammonia sulfate plant or sulfuric acid plant, demineralization, etc., where we will be having the wastewater. So that wastewaters you can directly send it to the effluent. If it is from phosphoric acid plant or DAP plant, that is diammonium phosphate plant, it has to be taken to the chalk pond, then to the mixing tank where it will be added with it of the lime because of this acids, it will be get neutralized. Then it will be taken to the settling tank where it will be get settled as lime sludge and it will be sent for disposal, while the other effluent can be removed to that of your effluent and it can be sent for the disposal. So this is a flow diagram for effluent treatment of a complex fertilizer plant. Apart from this nitrification and denitrification, there are other processes where this ammonia could be easily treated and it can be recovered so that it can be used. So this are the treatment of ammonia bearing waste by the other means, where we could go for steam stripping or air stripping in towers, and lagooning after pH adjustment, and biological nitrification and denitrification process. So what is steam stripping? This is a picture which depicts you how the steam stripping is done. You will be able to see here. So what is that is, the steam is passed through a plate packed bed, packed column, which will be packed with some since it is it is nitrogenous fertilizers or phosphate fertilizer where ammonia has to be removed. It has to be fertilized either with a natural medium or with the artificial chemical medium. So that what happens here, when the stream is passed from the bottom and your cold feed which is consisting of ammonia, or it will be get passed up, stripped up from the top, it is getting stripping off. So what happens is the steam will be able to remove this ammonia and it will be get it will be sent to that of the condenser and then it will be taken to that of the product. Okay, while the treated wastewater can be used for the other purposes, because ammonia is easily soluble in water stream. So that's why we are going for the steam stripping. But it is uneconomical because compared to air stripping, since we have to make the process of steam, that is we have to manufacture or create the steam and we have to send it to the stripper. So it's uneconomical by using the steam stripping. So the other way is air stripping, that is the same process, but instead of steam where we will get from the boilers, we will get directly injecting the air into this packed bed. So that what happens is the ammonia will be stripping at the top, and when this air is passed through this, it will be get cleaned up, that is ammonia will be get removed, and the pure water you can go for removing it up. And the other way of removing this ammonia is by using lagooning. It is a natural treatment technique where a pond will be created. Either it can be natural or as well as man-made, like stabilization ponds, where there will be a series of physical or biochemical and biological reactions will take place. But before lagooning, this wastewater has to be given preliminary treatments and then it has to be sent to the lagooning process. And the last process of this fertilizer ammonia treatment is nitrification and denitrification. So what is nitrification? It is a process by which ammonia will be first converted to nitrites and then nitrates. So this is this is done with the help of some nitrifying bacteria like Nitrosomonas and Nitrobacter. So where that ammonia will be first converted to nitrites as well as nitrates. Then in denitrification process, with the help of other microbial bacteria, this nitrate will be further reduced and it will be producing into molecular nitrogen. through a series of intermediate gaseous nitrogen oxide products. So these are the four ways where you can go for ammonia removal. One is, as I already said, by steam stripping, and second one is by air stripping, and third one is by using lagooning methods, and fourth one is by using denitrification as well as nitrification and denitrification techniques. So this is proved to be a effective treatment for removal of ammonia from that of your fertilizer plant waste. So in the next session we will be seeing the other industries. Thank you guys.